Hello guys, welcome back. Today we are going to understand the next question that we have on string based you can say DP, or you can say DP on strings, right, style. So we have already seen two questions, right, in this DP on string, that is the longest palindromic substring, and another was word break, right. So this is the third question that we are going to see today, the longest palindromic subsequence, right. And so this is also a DP on string questions, right, and how we are going to solve, right. You already understood the DP concept. Okay, so if you have not seen the other two questions, right, the DP on string questions like word break and those, so what you can do, you can go to the Expert Honda on YouTube, and you can find the DP on string style playlist, and please watch the series, or either I will put into the comment box. Okay, so let's understand the next question. So question we have 516, longest palindromic subsequence. So we have given a string S, and we have to find the longest palindromic subsequence in S, right. So a subsequence is a sequence that can be derived from another sequence by deleting some or no element without changing the order of the remaining element. Okay, let's suppose what we are trying to say here, we have given this a string, right, B B B A B. Okay, so it is saying that we can by deleting some or no element without changing, right. So if we will delete this one, right, so what will happen, remaining string will be 4 times B, right, and this will become your longest subsequence, you can longest subsequence. Okay, so this question is based on the DP on a string, and we are going to see how to develop the code, right, how to write the code. So actually what we have given here, we have given a string, right, as you can see in the example 1 and 2 also. So we have given a string S, and our task is to find the longest palindromic subsequence of length, whatever the length will come, right, like here we have 4. Okay, so if we are going to see in the recursive way, right, recursive DP approach, you can say, right. So what we will do, you have to find the way how to the recursively we will try to find the answer, right. So in this approach, let's suppose we have this is a recursive dynamic approach we have, right. So in this approach, what we will do, we'll try to solve this problem, right, how to generate all the subsequence of the given string S, right, and we will find the longest substring, palindromic substring, among all the generated substring. Means we will find all the subsequence, right, and within that subsequence, what we will do, we will make a checklist, right, check, and then we can find the longest palindromic string. Okay, in which we have already generated all others, right. So let's suppose we have total of some string, right. So what we will do, we will write a recursive function, and we will generate all the possible strings. So if the first and the last characters are same, right, means both characters are guaranteed to be considered in the final palindrome, right. What I'm trying to say, let's suppose we have given B B B A B, right, like this we have given. So what we will do, we'll start from I plus here and J plus here, J here, means I at 0, 1 2 3 4, like this. Okay, so I will go like this and J will come like this. Okay, means I we have to increase and J we have to decrease, right, and then we will generate all the possible strings, right. So if you will see here how we are going to see. Okay, so if B is equal to, let's suppose we have given a string S at I, right, that is what we have B. If it equal to S of at J, means at the last position 4, right, means S of 0 is equal to S of 4, right, means here is B equal to b, right? It means it's true, right? If it is true, means one character is here and one character is here, means two character we have already traversed and our length is now 2, but remainings we have here, right? Remaining 3 elements is still we have, right? So for that, what we will do, we will increase I will become now this one, and j we will decrease this one, right? And then we will do whatever the function we have, right? That function, let's suppose we have LPS, right? So we'll say I plus 1 now, and now we will check j minus 1, right? Means we have to decrease and I have to increase, right? And whatever this function will give you, that will become that we are going to add here. Let's suppose this function will give you 2, right? So what will happen? 2 plus 2, it will give you 4. And how it will give, that we will see, right? Okay, so now we have a recursive function, that is rule 1. If s at I equal to s at j, then we will do 2 character, means already 2 character is matched, right? So 2 plus, we will increase I plus 1 and reduce j minus 1, right? Like this. From here you can see, okay? And if the condition was here, LPS I plus 1 j minus 1, right? If it is not equal, let's suppose the character that we have taken here is not equal, we have b a, like this, okay? After increasing, now I is at what? Here. J is at what? Here, right? So if I will going to check, if I am going to check s of I is equal to what? S of j, but it is not equal to, right? It means we have to check what? We can check like these 2 letters or these 2 letters, right? Means I will remain same, but j will reduce to j minus 1, right? So you can see here, we will check I and j minus 1, and here if we'll take these 2, means we have to increase what? I plus 1 and j will remain same, right? So these 2 we will check, LPS of this and LPS of this, right? We can check 2 possibilities. If so, from here to here we are getting 2, and from here to here we are getting 0, right? It is not matching, right? It will not match. Then we will check the what, which is maximum, correct? So maximum will come from where? You will take here, right? So what we will do, we'll get 2 here, and here 0, right? Now these 2 and earlier these 2 will do what? Do plus, right? And then we'll say the answer will be your 4, 2 plus 2, and we will return this, okay? So in this way we will do the recursive calls, right? And we will find the answer. Let me erase all this and then we will discuss again, okay? So now you have understood that you have 2 things, right? First, the recursive method, right? That LPS will take care of I and j, right? If both are equal, we will do 2 plus LPS I plus 1 and j minus 1, means the I, that is the left index, will increase and the right index will decrease, right? As you can see. Now if both are not matching, then j will reduce, or another case I plus 1 will increase, right? Like this we will do. Means to calculate anything, there is 2 ways. If it is matching, we will go like this. If it is not matching, we will find the max, okay? So let's suppose we have a function, right, that we are taking 0 or n minus 1 length. If the both character at starting index and the last index is matching, right, characters, then we'll say 2 plus, and the LPS of will go to 1 to n minus 1, means we are increasing I and reducing j, right? If they are not matching, the first character and the last character, we will find the maximum of 0 to like I to j minus 1, or and I to I plus 1 to j minus 1, right? Like j till the j, whichever we come max, that will come here, and we'll find the answer. So this is called recursive way, right? And we will, in the recursive way, what we will do, we'll find the dynamic programming, right? So in the dynamic programming, what we will do, we will just add a memo, right? Let's suppose how we are going to do. Okay, so first of all, we'll take length n of n, right, of memo, and this is your I and this is your j, right? So this is LPS, this is your I, this is your j, and we will pass the memo. First, if memo contains not equal to 0, means what we are trying to say, we'll create a memo of this one, right? This, okay. And is there, if this is I and this is j, right? So every character initially will have default value 0, right? If we will calculate the particular value, so that will not be 0. Let's suppose we have already calculated this one, okay? So this is now 2, right? So if not equal to this, then means we have already calculated, we will return this data. And if I is greater than 0, I is greater than j, means return 0. If it equal to, means we have to return 1, right? Now when both characters are same, right, then what we are doing, we are doing plus 2 plus I plus 1 and j minus 1, that we are seeing, and we'll store at memo at I and j. If both are not equal, then what we will do, we'll say I plus 1 and j minus 1, and whichever is max, that will store here at I and j, and will return memo, right? So in this way, what will happen, we will traverse all the possible ways, either if it is equal, or like the first character and the last character are equal, or if not equal, right? So as you can see here, we are going with I and j, right? Means 2 loops internally it's taking, right? So yeah, you can say 2 characters we are taking, right? And we are going to the memo, right? And it is 2D, right? So if n is the length of the you can say string, so we will take what, n into n times for the matrix, this one, and so that the time complexity will become O of n square, you can say, that is your TC, okay. And for the space also, we are taking the 2D matrix for the memo, so it will take O of n square, right? And because the recursive stack used in the solution can be grow in the maximum size of O of n, right? And then we will try to form the recursive tree, and we see that there are maximum of 2 branches that can be formed. Either you can I equal to j, s at I equal to s at I, or equal to s of j, or not. If it is not, then we will make 2 branches, right? So like this, it will increase, and your time complexity, space complexity become of n square, right? So thank you guys, thank you for watching this video. If you really like this video, please hit subscribe this channel, and please watch all these 3 videos that I have already made onto our expert funda, the DP on string, right? So that playlist is very important for you for any interview, including FANGs and all top notch companies, right? Thank you guys, thank you for watching this video.